In this video, we want to start having a look at sequences and series. But to begin with, we want to focus on the two main sequences that you deal with in grade 12. Now, it might seem confusing at first using this new word sequences, but it's important to remember that sequences are just number patterns. So this is something that we've dealt with time and time again since grade 9. But now, because you're in matric, we decide we need to make your lives more difficult. And instead of calling them linear patterns like normal, we now call them arithmetic patterns. So an arithmetic sequence is basically just a linear number pattern. And we're going to work with it in the same way that we've done since grade 9. Another word for sequences, though, is this word here, progressions. And it's actually very nice for us to think of number patterns as progressions, because basically we're progressing from one term to the next. So if I maybe gave you a pattern like this, let's say 3, 6, 9, 12, etc., etc. The first question that you need to be asking yourself is, how do I get from this first term there, that 3, to the next term there? And how do I progress onwards and onwards? And hopefully you see that in this case, every time we move from one term to the next, we go about adding 3. And these set of numbers that we get when we add all them together, those numbers there, that we call the first difference. And if we have a pattern where all of these first differences are the same, we then know it's a linear number pattern or an arithmetic sequence. So it's your job in tests or exams to start off by looking at what kind of pattern you have, by figuring out how are we getting from one term to the next. How are we basically progressing from term 1 to term 2 and so on and so forth. Now, another way of thinking of these terms is to write it out a little bit like this. So we always say that the first term in a number pattern is A. If you think back to grade 11, to grade 10, we always said that the first term is A. We also then said that the difference between terms, the first difference that we spoke about here, between terms, we use the letter D. So to get from the first term to the second term, we're going to add that difference, which would make the second term A plus D. And then to get from the second term to the third term, we've got to add that difference again. So now we've got A plus D plus another D, which gives us A plus 2D. And then to get to the next term, we've got to add that difference again. And so we would get A plus 3D. And we can basically see from this that if this is where n equals 1, and that's where n equals 2, 3, and 4, the number of differences that we get is always going to be 1 less than the term. So 2 differences, 1 less than the term, so n would be 3. 3 differences, 1 less than the term we're in, so n would be 4. And you can use this idea actually to help you with more complicated problems as we go on throughout this section. But just to define the general term for you then, again, going back to something you've dealt with before, is that Tn is equal to A plus n minus 1 times that difference D. And from each of those things, you need to understand that the Tn, that refers to basically your term number. Now that sounds weird, but all it means is the actual number in the pattern at whatever the position is. So in this case, at position n. Then A, you should know by now, A stands for term 1. You can also think of it as being the first term. N is obviously your position that we've spoken about already. So N is position. And the D means difference. And just another way of writing out the difference as kind of a formula is that the difference is equal to Tn minus 1, like so. You can see that the subscripts there are n and n minus 1. And even though that may sound difficult, it just means take the term in the higher position, not the higher value, the higher position minus the term in the lower position. So something like T2 minus T1, or T99 minus T98. So basically 2 consecutive terms where we've got higher position minus lower position. So those are the parts that make up an arithmetic sequence. Don't forget these because they are useful when dealing with arithmetic series as well, which we're going to come on to. But let's maybe focus in on a few examples that'll put these formulas into action. So this is the first example we'll look at to apply arithmetic sequences. So first things first, we've got to go and look at the pattern which we're given over here. And we've got to ask ourselves, what kind of pattern are we dealing with? Because tests and exams aren't going to specifically tell you most of the time. So we've got to look here and say, how do I progress from term 1 to term 2 and from term 2 to term 3? And hopefully most of you see there that this is a term where we are subtracting 5 each time. And because we're subtracting 5 each time, we're seeing that we're getting a constant first difference. And that tells me that we are dealing with an arithmetic sequence. In this arithmetic sequence, the a value, which is the first term, so in other words, the 12 there, is given to us. And the difference, we've already kind of worked out for ourselves as negative 5. But if you wanted to maybe test it on the side, you could go and see that the difference would simply be T2 minus T1, which is 7 minus 12, which is negative 5. Or again, we could go and maybe use the T3 minus the T2. Any 2 consecutive terms where we take higher position minus lower position. So 2 minus 7 also gives us negative 5. So all of those tell us that we're working here with a constant first difference of negative 5. So the question then says, determine the general term of the sequence. The word general term, that also means nth term. And it's basically saying, figure out what Tn is. So we know that Tn is a plus n minus 1 times the difference. The a value in this case is 12 plus n minus 1 times the negative 5. Keep this in a bracket so that you don't go and make stupid mistakes when you distribute. And then we're going to get 12. That 5 goes to the n and the negative 1. So it's going to be minus 5n plus 5. We go and simplify it out and group up the like terms. And we get minus 5n plus 17. And that is the sequence that we're dealing with here. You never plug a value in for n in the general term because we want it to have n in the actual answer itself. The second question then says, determine the value of the 100th term. So that's basically saying, tell me what term 100 is. So we're not talking about position, we're talking about actual value, which means that from that we can take away that n is going to equal 100. So T100 is equaled to minus 5 times 100 plus 17. And you can get out your calculator to work that out for us. So we got minus 5 times 100 plus 17 gives us minus 483. So the 100th term is minus 483. The last question then says, which term is equal to negative 298. Now, this is difficult for us because we need to kind of understand, are we subbing in a value for n, or are we subbing in a value for tn? And you should be able to see that it's asking us which term has a value of negative 298. So that means that the actual tn is equal to negative 298. But another hint here is the fact that this is a negative number. And you can make a note for yourself throughout this entire chapter that n can only be a natural number. It can never be a negative number. Okay, so n can only be a natural number. So from that, we go and sub it in for tn. We get minus 298 is equal to minus 5n plus 17. And we are solving this equation for n. We're going to move that 17 over. And when we do that, we're going to end up, if we take back our calculator, minus 298 minus 17 when we move it over is negative 315. So negative 315 equals negative 5n. Divide both sides by negative 5, and we get 63. So in other words, putting this all together, term 63 equals negative 298. And that's the answer to the first question that we'll deal with here. This is the second example that we'll have a look at regarding arithmetic sequences, but this one's a little bit more challenging. So we've got a question here that says the 13th and 7th terms of an arithmetic sequence are 15 and 51 respectively. Which term of the sequence is equal to negative 21? One of the most important skills that we can develop in this section is being able to take a sentence like is written over here and convert it into maths. So they're telling us that firstly, the 13th term there, which would be T13, and of course the 7th term over there, which is going to be T7 for us, have the values 15 and 51. So putting that together for ourselves, we can see that T13 is equaled to 15 and T7 is equal to 51. And for these values, we know that over here for the first one, n is equal to 13, and for the second one there, n is equal to 7. So we could actually write it slightly differently using the idea that we mentioned in the beginning, which said every progressive term in an arithmetic sequence looks something like this, where the number of differences is one less than the term that we'll be dealing with. So that would basically mean that for the 13th term, we could say that a plus 12d, because it's going to be one less than the 13, would equal 15 for the 13th term. And a plus 6d, because again, it's going to be one less than the 7th term, is going to equal 51. This skill over here is extremely important for problem-solving type questions, because what it's done is given us two equations that we can use simultaneously to now go and solve any of these questions. So the easiest way to do this is to use substitution or elimination, whichever one is easier for you. But let's do that. In equation 1, we see that a is going to be 15 minus 12d. So if we go and sub that first equation into the second equation, we're going to get 15 minus 12d plus 6d is equal to 51. And if we move over then, we're going to see that it's 15 minus 6 differences is equal to 51. We're going to go ahead and move that 15 over. So we get negative 6 differences is equal to 36. Divide both sides by negative 6 and we get the difference is equal to negative 6, like so. And that does make sense because we can see that the 13th term is 15 and the 7th term is 51. So it means that we're actually decreasing the sequence as we go through each number in the pattern. And so we can go back then and work out the A value, which is going to be 15 minus 12 times negative 6. And I think it's easiest to just do that on the calculator. So we got 15 minus 12 times negative 6. That gives us 87. So we know that the first term is 87. From all this information gathered, the question then says, which term is equal to negative 21? So let's go put it all together. We've now got the A value. We've got the difference. So we can actually find our nth term. So we know that Tn is A plus n minus 1 times the difference. The A value is 87 plus n minus 1 times the difference of negative 6. Grouping up the like terms, we're going to get negative 6n plus 93, like so. And so the term that is going to equal negative 21 that it's asking for is where we go and make Tn negative 21. And again, the reason for that is because it's asking which term will have a number equal to negative 21, not which term has a position negative 21. And the fact that it's negative again tells us it cannot be the n value. So there we've got that negative 21 is equal to minus 6n plus 93. Again, let's go and use the calculator and say negative 21 minus 93 is equal to negative 114 is equal to minus 6n. Divide both sides by negative 6 and we get that n is equal to 19. So from that, the 19th term, T19, is equal to negative 21. So I hope this example helped, especially with the more difficult kind of problem-solving questions. That's all we're going to do on arithmetic sequences. The next video is going to touch on geometric sequences just before we start getting into series.